Okay, well, a couple things. Hope everybody's doing all right today. We're going to go ahead and after the focus activity, which they're due next week, you'll get your sixth and final one on Tuesday. We'll turn those in Wednesday. Should be a really good way to end the 6 weeks. Just a good quiz grade. Just have all three of them. Make sure to bring those on that day or turn them in early on Tuesday if you want to go ahead and do so. What I'm looking forward to, the big item is going to be the exam coming up on Monday. So it's going to have a couple of concepts on there. It's going to have the graphing and analyzing rational functions, which we've been talking about. We're going to discuss that quiz very quickly that we had yesterday, and I went ahead and passed that back. Your class average was a 77.8. Okay, so I'm happy with that. That's good. The other part is going to be composition of functions. We're going to start that today, continue it tomorrow. Probably finish it on Friday. If we don't finish it tomorrow, we'll kind of see how that plays out. But we are going to have another quiz tomorrow over rational functions because I really want to make sure that you're comfortable with the material. Okay, so we'll be looking ahead to that. And I think that's pretty much it. Have I mentioned that we're getting a student from Texas Tech? Okay, so starting tomorrow. Now, I don't know if this is going to be for the semester or if it's going to be for the rest of the year, but we have a student from Texas Tech joining us. She is joining the profession, and basically she's going to do a little more than observing. So maybe on Thursdays, she could be teaching you guys a lesson. She'll be going to a focus activity with you. She might be grading, but basically she's going to come in and I'm going to show her the ropes, what it means to be a teacher. Okay? And we'll see how that works out. So here's my focus activity. During a 2-week period, Muriel took her umbrella with her on 8 days. It rained on 9 days, and Muriel took her umbrella on 5 of the days when it rained. Display this information on a Venn diagram. Okay. So here's my universe. Now, very quickly, how many items are in this universe? Okay, so how much time? There we go, 14 days. I didn't want to go ahead and say days because I didn't want to immediately give it away, but this is over a 2-week period. Okay, so we should be looking at 14 days total. So there are some days that it rained, some days she brought her umbrella. Not one. Okay, hello. So we know we're going to have a couple of overlapping circles here. Why don't we go ahead and say the days she brought her umbrella, let's say UM for umbrella. That way, you know, we don't confuse the U with the universe. And then for the days it rain, we'll just say R. Okay. So what do we know? Where can I start putting values in the Venn diagram?
Took umbrella 8 days.
Okay, so took her umbrella 8 days. So I know that within this circle, whatever values I have has to add up to 8. In the middle, we're going to put 5. Okay, because it does say she took her umbrella 5 of the days it rained. Okay, so there's an intersection there. So Andrea just said she took it 8 days total. So how many days will she have taken her umbrella that it didn't rain? 3. It's going to be in this little section right here. And it rained for a total of 9 days. So how many days did it rain and she did not bring her umbrella? 4. Is everybody seeing how I'm filling it in? Any questions? Now, is there anything I'm forgetting? 3? We're very close. What do you mean 2? There you go. If you go ahead and add up these values here, 3 plus 5 plus 4, that's only 12 of the 14 days. So that means there's 2 days still in the universe that she didn't bring her umbrella and it did not rain. So we still want it in the rectangle, but not in one of those sets. Okay, so A is taken care of. And now B1, or BI, how you want to say it, hence the number, find the number of days that Muriel did not take her umbrella and it rained. So let's go ahead and rewrite this as a mathematical expression. But it says she did not take her umbrella. What's that trying to get us to think about with sets? It starts with a C. What's that? The complement, yes. Okay, so we're saying that umbrella is the UM. So the days that she did not bring her umbrella. Remember, that's all the values in the universe, but not in that particular set. And what uses the keyword and? Was that intersection or union? Intersection, there we go. So this is an intersection. In fact, what keyword would be a union? Or, there we go. And is intersection, union is or. And then it rained. So I'm going to go ahead and say R. So let's see. What would be the intersection of her not taking her umbrella and it raining? It would just be 4. Yeah, that makes sense. There are 4 days when it rained, but she did not have her umbrella. Does anybody want me to show you that by shading? You didn't want me to? Okay. So let's say, let's do it this way. Let's go ahead and say that green will represent the shading for the complement of the umbrella. And let's say that purple is going to represent the days that it rained. Okay, well, remember the complement is everything in the universe, but not in that set. So what's going to be shaded green? Oh, of course, I'm still on that. Yep. Okay. It's going to be everything outside that circle, right? Okay. And now I want to go ahead and shade everything that rained. Remember, we're going to do that one in purple. Okay. So I've got these 2 overlapping areas. Remember, the intersection, that's what they both share. Okay. So they both have this one crescent region right here with the 4. Okay. Does that kind of help to visualize it? Okay. So let's see how fastly I can get that. Hey, that worked out pretty well. Okay. And now B2, or, not 2B, whatever thing. 2B, not 2B. It's an English joke. I know this isn't an English class, but we always get lit. Okay. Literature. Yeah, okay. Moving on. Muriel did not take her umbrella, and it did not rain. Okay, so again, not doing these things would be the complement. So she did not take her umbrella, and it did not rain. That's the 2. That's the 2 days that we have in the universe, but not within those sets. Yes. Excellent. Okay, any questions on that? Okay. All right, so go ahead and put that with number 4. Remember, we've already taken care of 1 through 3. We don't have to look at those. If you've lost or misplaced number 4, I do have copies over in the filing cabinet right over here next to Adolfo. All right. So let's go ahead and take a look at that quiz very quickly. Did I put it here? No, I think I put it right here. I think I put it at the end. Could have sworn I had taken pictures of that. There's the assignment. Oh, no, I think I did it on the focus activity. That's right, that's right. Here we go. Okay. I knew I'd taken snapshots of it. I just couldn't remember where I put it. Okay, so this is the quiz that you guys took yesterday. A lot of folks did really well. Some folks probably did a little lower than they would have liked, and that's okay. Remember, you can retake. If you have questions, come ask me. But let's take a look. It says f of x equals 2x squared over x squared minus 4. Okay. The first thing I would do is factor anything possible. Now, 2x squared, I can't do anything with it. But what kind of polynomial is x squared minus 4? That's a difference of squares, yes. We get what's called conjugates. So 2x squared divided by x squared minus 4. Okay, well, that would equal 2x squared over. You might know what they would be? X plus 2, x minus 2, yes. Okay. Now, when we're asked to find the vertical asymptotes, and let me take a step back for a second. Would this guy have a hole? There is no hole here. Now, how do we know that? There you go. There is nothing between the numerator and denominator that cancels. So that was one less thing to worry about. Okay, there's no hole. Okay. Now, if I'm looking for the vertical asymptotes, remember, what was the shortcut? There's something I set equal to 0. Set the denominator. So for the vertical asymptotes, set that denominator equal to 0. Okay. Well, x plus 2 times x minus 2 equals 0. Remember, that's just the zero product property. So I'm going to take each of these two groups. If x plus 2 is equal to 0, and then I subtract 2, well, x equals negative 2. That's one of my vertical asymptotes. Okay. And remember, you always want to give me the equation. So x equals or y equals. The other one, x minus 2, is equal to 0. So I'm going to add 2 to both sides. Those cancel again. So x equals 2. So this guy has 2 vertical asymptotes. Okay. Any questions on that? Okay. Well, now it says find the horizontal asymptotes. Now remember, for these, you want to think about your 3 cases when it comes to the degrees. Rhett, would you take care of that? Thanks. Okay. So what am I referring to? Like what cases here? Okay, the powers. What do we see about the powers? There you go. Okay. We have one case where the numerator's degree may be larger. We have one where the denominator's degree may be larger. Or we have this one where the degrees are the same. So what do we do if the degrees are the same? Okay. Nathan says we take the ratio. So these coefficients right here, all we do is divide them. So what's 2 divided by 1? 2. So right away, I know that I have a horizontal asymptote, y equals 2. Okay. Now remember, if the denominator's degree is larger, that's the x-axis, y equals 0. What happens if the numerator's degree is larger? That's a slant. That's when you have to go ahead and use division, okay, like synthetic division. Okay, good. So we're getting everything. Now it says state the intercepts, domain, and range. Okay. So intercepts, let's start with the x. What was the shortcut for the x-intercept? There was something else I want to set equal to 0. Brandon? Set the numerator equal to 0. Okay, well, let's take a look. Now, the numerator is just 2x squared, right? So let me put this right here. So for the x-intercept, set the numerator equal to 0. All right, well, the numerator is just 2x squared. Okay. Well, let's just go ahead and solve it. First, I have to divide by 2. Those cancel. So x squared is equal to 0. 0 divided by anything is 0, unless it's 0, of course, and then it's undefined. And how do I get rid of a square? Square root. Okay, so x is equal to 0. That would be my x-intercept. Okay. Now, remember, normally when we take a square root, we want to put plus or minus in front, but 0 is neither positive nor negative. Okay, and we want to go ahead and write that as an ordered pair. So I know that my x-intercept, parentheses before I put my 0, is going to be 0, 0. So that's my x-intercept. Now let's find my y-intercept. Well, what's the shortcut for finding the y-intercept? Yeah, just replace x with 0. So 2 times 0 squared, 0 squared minus 4. So it looks like I'm going to get 0 over what? Negative 4, right? And 0 divided by negative 4 is just 0. So what's my y-intercept? Yeah, it's at 0, 0. And that makes sense because this is the one place where both x and y intersect. So if an x-intercept is the origin, well, the y-intercept is going to be the exact same. Okay. All I want to do is go ahead and pull these together and draw my graph. So let's see, we had an asymptote at 2. We had a negative 2 asymptote. Let's see, we had a horizontal at 2. And remember, we've talked about not drawing the middle. Okay. I mean, you can if you want to, but it's possible your graph may go through there. Let's see. We know we're going to have 0, 0. All right. Well, the only thing left is to go ahead and figure out, okay, where my branches are going to be. And remember, to do that, we were just talking about plugging in some values. Okay. Now, on this number line right here, where this represents the x-axis, you want to put any values that made the denominator 0 and any intercepts, the x-intercepts. Okay. So, for example, I do want to put negative 2. I want to go ahead and put 0 because that's a x-intercept. And then I want to put positive 2. So all I want to do is just figure out where the curve is. If I plug in a number, I'm looking to get a positive or a negative. If I get a positive here, well, that means I'm going to have a curve above the x-axis. What if I get a negative here? That means the curve would be below, yeah. Okay, it would probably look something like that. Now, probably without even substitution, can anyone tell me on the far left, should it be above or below? Why above? There you go. We don't have any other x-intercept over here. So I'm willing to bet it should be above. Okay, so it's probably going to curve like this, right? So that means we should be getting a positive here. Well, let's test it. Give me a number smaller than -2. -3, perfect. So I'm going to take that -3, and I'm just going to plug it in. Remember, we had 2x squared over x plus 2, x minus 2. Okay. Now, what happens when you square a negative number? It always goes positive, right? So on top, I'm going to have a positive divided by it. -3 plus 2. That would be a negative number, right? And then what's -3 minus 2? Another negative. So two negatives will give me a positive. And what's a positive over a positive? There you go. Okay. Now you could do the same thing at the far right. Okay. But is it going to make more sense for the curve to be above or below? Why? Again, we don't have a what? There's no other x-intercept besides this guy right here. Okay. And there's only one region left. Now, because this is between two asymptotes here, I mean, it could look like a parabola, or maybe it could, kind of curve up through that. What ended up happening? It ended up looking like a parabola. Okay, so let's see what direction it goes. Somebody help me out. Let's say between 0 and 2. Give me a number. So let's say 1. Let's do the same thing. Let's plug 1 in here. 2 times 1 squared. Would that end up being a positive or a negative? That's a positive. Okay. Over. 1 plus 2? Positive. 1 minus 2? That's a negative. So what is this telling me? Between 0 and 2, should it be a positive or negative? Yeah, positive divided by negative is a negative. So I know that in this region right here, it should be below the x-axis. If you go ahead and plug in, you'll notice you get the same thing. So it's going to look something like this. Okay. And then we just go ahead and write my domain and range. Now, instead of using the interval notation, why don't we just go ahead and write it out? Now, the domain, I can go ahead and say that's all reals, okay, except what can x not equal? What were the two values of x that we had to throw out? -2 and +2. There we go. And then my range, let's see here. So again, that's again all reals, but this time, what is the only value that y can't equal? Only 2, because that's your horizontal asymptote. There we go. Okay, so tomorrow you'll get a problem, again, very similar to this. Okay? We'll go ahead and practice it again, getting ready for that test, because the rational graphing, all these ideas, is a big part of that exam. Now, remember, on the exam, you're still going to be able to use your notes. So anything you copy, anything you have is going to be fair game. Okay? All right. Good. Good. Well, let's go ahead and take a look at compositions. Ooh, I'm on the wrong page. Okay. So compositions of functions. Now, the good news is this is where you simply evaluate a function. Like if I had, I don't know, something like f of 3, what is that asking you to do? I replace every x with what? Yeah, I substitute in and I simplify. What we're going to start looking at are these guys right here. This is what we call a composition, where we go ahead and evaluate one function inside of another. So in this case, for e, f is what we call the inner function. H would be what we call the outer function. Okay. You always work from the inside out. And we're going to be doing these in a variety of ways. We're going to be looking at them from tables, graphs, and then finally the equations themselves. Okay. So these first three right here, A, B, and C, these are not compositions of functions. It's not one function or another. It's just kind of getting you accustomed to what the table is doing. Okay, so let's just get right into it. Let's see what you think. This one says -3 times h of o times g of -3. Now, I want to know what the value at function h when x is 0 will be. Okay, so on the table, I'm going to be looking at function h. So it's somewhere along this row. What value of x is it? Okay, here you go. When x is 0, see, you want to go ahead and line it up. So I don't know what the equation is, but whatever happens to 0, when I plug it into h, it's going to give me a 2. Okay, so I know this is -3 times 2. Now let's do the same thing for g. Okay, let's try that one more time. There, I almost got it. There you go. Now I want g of -3. So I'm going to be looking specifically at g's row when x is what? -3. So I go ahead and match those up. He's what? -2. That's how you use the table to find your value. Look at the appropriate row and the x value they're giving. Okay? So let's see. -3 times 2 times -2. 12. That would be 12. Okay. That's it. That's all there is to it. Okay. Let's try B. 2g of -1 divided by f of -2. Okay, so we won't worry about the 2 just yet. We have to evaluate the function. So let's see here. G of -1. So we're still in the same row. Okay, but we want -1. What's that give me? 7. Is everybody seeing how I'm using the table to find these? Okay, so this would be 2 times 7 divided by, now I want, this isn't working too well today. Now I want f of -2. So for the first time, I'm in the top row. What's the value of the function when x is -2? 3. And now we just simplify what we can. 2 times 7 being 14. There we go. Oh, no. Now remember, the -2 is what helped me get this 3 right here. Because see, the function f refers to an equation. We just don't know what it is. We've already been provided all the y values. Okay. So these ones, when you're dealing with the table or the graph, those are really nice because the work has already been done for you. It's when we get to the functions that we have to start plugging in. Okay. So Lilibel, help me out on this next one here. I want h of -2. So I want to go to h's row. But how do I know which of these is going to be my answer? What value of x am I plugging in? The -2. So I'm in the right row. Now make sure I'm in the right column. Okay. So just match them up. I know that h of -2 should be giving me -1. Plus 3 times. Now I got to figure out what g of -1 is. Okay, so now I'm in the second row, function g, when x is -1. There we go. So I go right here, -1 gives me 7. Is there anybody who's not seeing how I'm getting my values off the table? Okay. So let's see. 3 times 7, 21, plus -1. 20. There you go. Now, we're not going to worry about D. D and E are actually the same problem, and I'll talk more about that later. But E, this is our first example where we have a composition. We want to evaluate one function inside of another. Okay. Now, I want to go ahead and throw this out for you. This right here, where it says, for example, h of f of 2, depending on the textbook you use or the teacher that you have, it could be shown like this. Okay, that little circle right there, not a dot, that also means composition. Okay, so here we read h of f of 2. Well, here we would just say h composed with f of 2. Both of these are saying the exact same thing. Okay, so if you see it written with that circle, I just want you to realize, okay, we're still talking about composition. All right. So here's what we're going to do. You always start with your inside function because here's the idea. The output, the answer you get for the inside function becomes the input for the outside function. I know that sounds really confusing. I mean, even try saying it 3 times fast, right? But let's walk through one at a time. Forget about the h. I want to start with f of 2, just like we've been doing. So according to the table, what is function f when x is 2? It's 3, right? I know that f of 2 is equal to 3. And so you think about kind of the big picture. The 2 is an x value, right? What's the 3 represent? That's a y value. So this ordered pair 2, 3 is on function f, whatever he looks like. Okay, so what I'm saying is the output, the answer I get from the inside function, that's what I then plug into the next function. It's almost like you're substituting. I know that the value f of 2 is 3, so now I'm really wanting h of 3. The answer I got from the inside function, I place that directly into the next function. So now I want h of 3. So what's the value of function h when x is 3? Negative 1. So h of f of 2 is negative 1. It's like you're evaluating 2 functions simultaneously. You go from one directly into the other. Okay? So that might seem a little hazy, and that's okay. Let's try another one. Okay? Let's try f. Okay? So g of f of negative 3. Well, where do I start? With g or f? F. Always start with the innermost function. Okay? So I want to know what's f of negative 3. Okay, so f of negative 3 is 0, right? Okay, so all I'm going to do is replace f of 3 with that value that I just found. And now I'm going to evaluate g with that answer. So now what's g of 0? G of 0 is negative 2. That's my answer. That's what I'm looking for. That is g of f of negative 3. Okay, am I losing anybody? Anybody not sure how I'm getting my final answer? Okay. Okay, yes, ma'am. Well, I'm wondering if this isn't going to be a typo, because I'm wondering if instead of times, that shouldn't have been an open circle. Because this one doesn't belong here just yet. With what they've put, that would indicate to me that I want to multiply the 2 functions together. Because that's exactly what the dot is. And that's one of the things that I'm going to be showing you, if not tomorrow, then on Friday. Okay. So I'm really thinking maybe that was a mistake on this. Now, it's not my resource. See, and you're probably thinking, well, Mr. West, you would never make a mistake anyway, you know. It was a little too quiet when I said that. Okay. Let's try another one. How about h of g of negative 2? H of g of negative 2. Now, I'm going to have to go back over here and write it out, because mine are on 2 different screens. So h of g of negative 2. Okay, so where do I start? H or g? Okay, what's that? No, we're on h of g of negative 2. So I want to start with h or g. Well, we're on g, yes. The very next one. So we are starting with g, that's right. So I need to figure out what's the value g of negative 2. Can anybody help me out? What's g of negative 2? Yeah, so here's g, negative 2. Again, you're just finding where they hit, where the row and the column intersect. So if g of negative 2 is 1, then I now want to place that 1 into the very next function. You just go in order. So now, Rhett, help me out. What's h of 1? Negative 3. Function h when x is 1. That's my answer. Anybody confused? How are we doing? Okay. You're doing good? Okay. All right. I think we are a little too excited. I think we need to compose ourselves. It's composition. Yeah, okay. Compose ourselves, composition, comp function. I don't feel it's as funny as if I have to explain it, so that's okay. Let's move on. G of f of 3. Okay. G of f of 3. So I'm going to come back over here. G of f of 3. Okay. So where do I start? G or F? F. Always start with the inside. Okay. So let's see here. Andrea, what is f of 3?
F of 3.
Yes.
Gonna be 2.
So I come all the way down here. She's absolutely right. So I'm going to replace f of 3 with the answer I got from the table, 2. But see, I'm going to plug that directly into the next function. So now I want g of 2. Okay. And let's see. Alistair? Oh, she says 5. Is she right? G of 2, 5. Perfect. That's it. That's all there is to it. That's composition of functions. Okay. Now, I'm going to go ahead and leave this up to you. There are a few others that I would like to do, probably like definitely J, K, or L. Do we want to go ahead and do I? Or do you guys want the extra practice? You want to try it on your own? Practice? Okay. Why don't I give you 30 seconds? Try it on your own. F of H of 1. F of H of 1. Yes, ma'am. Yeah, go real fast. I'm sorry, what? Now, I would say do I if you're feeling ambitious, if you feel like you could do it, go for it. The only difference between what we've done and JKL is that you have one additional function. You just have multiple functions to evaluate, but you just go straight from one into the other. Okay.
So right here, I find the innermost.
Yes. So first you find f of 2,
and then I find
plug that
G
into G,
that,
and then plug that
okay.
in. Yes. So you just continue working your way out. Okay. So what are we getting for f of H of 1? Okay. F of H of 1, final answer is 0? Okay. All right. Now, do we need to run through it, or you guys feel comfortable? You want to run through it? Oh, I'm sorry. I'm sorry, I can't hear. I'm old. Or I guess I shouldn't say I'm old. I'm unyoung. Let's say that.
You're
I'm unyoung. It sounds more PC. There you go. Politically correct. Politically correct. Yeah. It's like I'm not going to say I'm bald. Let's say I'm follically challenged. Thank you. Thank you. Yes. You know, hair today, gone tomorrow. Oh, hey, look, math. Okay. J, let's try this one. H of G of F of 2. Okay, good. All right, so let's see how he got that answer, because Angel's already saying 1/2. So H of G of F of 2. So H of G of F of 2. All you want to do is just work from the innermost function out, what I was just discussing with Rhett. So first, what's F of 2? So function F when x is 2, that gives me 3, right? So I'm just going to replace F of 2 with 3. So now I have H of G of 3. So now the next function is G at 3, which I come all the way down here. What is that?
negative.
-3. So once again, I'm going to replace that with the answer I have, and I'm going to plug it directly into the final function. So now H of -3, that is 1/2. Angel's absolutely right. Okay. In fact, has anybody taken a look at K? I got -2. That is absolutely correct. So K is -2. What do we get for L? -3. Okay. Does anybody want to run through one of those real fast? Okay. Now, I'm going to go ahead and do this. I do want to take a look at M and N, but let's save that for tomorrow because I want to go ahead and at least show you another method this can be done. Is anybody having trouble with the table? Okay. Now, another way we could do this is if we're given the graph. Now, see, technically, we are still provided a table because I know points that are going to be on the graph. Like, for example, this point right here, well, that's going to be 3, 3, right? But that's what you're going to want to do. You're still provided some value of x. You want to go up or down depending on where the graph is and find the y value that corresponds to that. Okay? So let's try a couple of these first without compositions. So a is negative 3 times f of 2 plus g of negative 3. So you'll notice you've got two functions, f and g. You want to make sure you're in the correct graph, because if you're in the wrong graph, you're most likely going to get the wrong answer. So let's look at f of 2. I definitely want to be in graph f. Well, here's 2 right here. From here, would I go up or down? Up, because the graph is above it, right? As soon as I hit the graph, I want to go over to the y-axis and see what point corresponds to that. So what is f of 2? 2. So this is negative 3 times 2 plus. Now I want to do the same thing for g of negative 3. But I'm not in the same graph, right? No, now that it's g of negative 3, I want to make sure that I'm in the right graph. That's exactly right. See, here's negative 3 right here. But this time I have to go down, because remember the y values are vertical. X moves left or right, y moves up or down. I go down because that's where the graph is. Takes me right to where I need to be, negative 2. So see, it's just another way of evaluating these functions. We're just doing it graphically. I know that might seem a little sketchy.
Someone's laughing.
Might seem a little sketchy. That was perfect. I'll probably look at that in just a second. I'm kind of worried today. My dad's actually in the hospital. He's having an angiogram performed. So if I can't wait. I need to know. I'm sorry. Let's see here. Okay, they just took him back, so they're about to perform the test. Okay, anyways. All right, so what would negative 3 times 2 be? Okay, negative 6 and then minus 2 would give me negative 8. Yes. Perfect. Okay, well, let's go ahead and try this one, B. Now, g of 3. So again, I want to make sure I'm in the right graph. What value of x am I interested in? Okay, we're in g, but what x value? 3. So in graph G, here's my 3 right here. So I'm going to go up, straight over. What is g of 3? 1. Minus. Now F tells me I want to jump graphs. I'm going to go to the other one. And I'm very interested in negative 1. So let's see, over here in function F, okay, when x is negative 1 right here, I'm going to go down because that's where the graph is, and straight over. What's that? Negative 3. But what happens when you subtract a negative? It becomes positive. So this actually should be what? Oh, 1 plus 3? 4. When you subtract a negative, that turns to positive. Okay. Yes, sir. Oh, yes. So yeah, I was, just making sure you guys are paying attention. Got to keep you on your toes somehow. I'm unyoung. There you go. Okay. Now, let's go ahead and at least get away with one composition on this before we get out of here. Let's try g of f of negative 1. So help me out. F of negative 1. Well, didn't we just find that? Yeah. F at negative 1 was negative 3, right? So if f at negative 1 was negative 3, I'm going to plug that directly into the next function, just like we were doing before. So now I want to jump graphs. When x is negative 3, what's the y value? Negative 2. Is everybody okay with that? Is there anybody who's not seeing where we're getting these values from? Okay, good, good, good. We'll continue this tomorrow. We'll have our quiz. Guys, thank you so much. Have a great day.